How are you, Ania? Hello, how are you doing, Ania?
I'm good. How are you?
Fine, thank you. So I think we're gonna begin in the okay, I think somebody Mr. Taylor, right? How are you doing? Nick, you there? All right, I think we can begin. Um, so let me start by sharing my screen. I think we lost Nick. Okay, Mr. Bennett, Miss Bennett. Okay, good. Everyone, how are you all doing?
Yeah.
Very good. Now we are rounding up. Today we do regression and correlation for simple regression, and on Monday we do multiple one. So then probably I believe we will complete everything by Wednesday, so that we don't have to come to class on Friday next week. Just use that to prepare for your final exam. Again, your final exam will just be 10 questions. I'm gonna pick one question from each topic we covered, and then it will be taken in Pearson like before. So it's not nothing to panic. It's just part of your grade, you know. Anyway, today we have correlation and regression. Now, what are correlation and regression? Correlation tell us basically it measures how or the extent to which two or more variables move together. Regression attempt to determine the strength of relationship between two variables. So that's the things that we'll be talking about in simple regression and in multiple regression. So before we proceed, I want to explain some key points, and then we can go from there. Okay, let's make it bigger. Now, some of the questions that can be answered using correlation and regression, we have things like a business owner might want to know if advertisements and sales are related. I mean, if he or she get more sales when they advertise more, things like that. Now, we in the education field, we like to know whether the hours you spent studying can push up your grade. Yeah. Sometimes you may spend so much hours studying for the test, and then you still get a wrong grade because maybe you studied the wrong thing, or on the exam date you came late and was in a hurry and make so many mistakes that bring your grade down. But generally, we believe that there might be a relationship between hours you spend studying in terms of pushing up your grade. Anyway, now medical researchers might have questions like, does age and blood pressure, are they related? Can COVID-19 vaccine truly protect us? So different fields have this kind of question about things. So to answer this question, we bring two variables together. Two variables. We have two types of variables that we use. One is the dependent variable, which we call the Y variable. So the dependent variables are those variables that can be, controlled or manipulated. For example, the one I mentioned about the business owner trying to figure out if sales and advertisement are related. The dependent variable there will be advertisement, because you can decide how much you spend on advertisement. You can decide how many times you advertise, but you cannot decide how much sales you will get from that advertisement. You have no control over the sales. You can influence it through advertisement, but you don't have a direct control over it. But for advertisement, you have direct control. You can say, I'm going to spend only $500 this month on advertisement. So those variables that you can control, or that the researcher can control, we call it the dependent variable. Sorry, my mistake. My mistake. Those variables you cannot control, that you can't control are the dependent variable. Cells, for example, you cannot control it. But those variables you can control are the independent variables. Like you can decide how much you spend in advertisement, you can control that. But you cannot control the cells that will come from the advertisement. Also, when it comes to vaccine and COVID-19, the researchers or can decide to give 1 million vaccine, 10 million vaccine, but they cannot control how effective that vaccine will be in terms of, protecting people from COVID-19. Some people have the COVID-19 vaccine and yet have the virus, So those variables you can control are the independent variable. We call it the X variable. Those you cannot control are the dependent variable or the Y variable. There are many examples of that. Hours of study, you can control that. So it's the independent variable or the X variable. But your grade, you cannot control it directly. That is the dependent variable. Questions on this?
No questions.
Good. Now, correlation coefficients we use the symbol rho to represent it. It is the numerical measure of the degree in which two variables are related. So we have with the symbol rho, and it is a different type of correlation called a Pearson correlation coefficient. It was named about the name was derived from the mathematician who first derived the formula for it. So it tells us the extent of relationship between two variables. For example, it usually goes from I'll show you how it goes. The range of values for the correlation coefficients. Range of values or the correlation coefficients are. Now, remember it is rho, but we don't know rho is the population correlation coefficient, but this is we try to predict it using the sample correlation coefficient R. So range of values, the values goes from, I'll put it this way, okay, this is how it goes. At the middle of this is the no correlation. That means no linear relationship, no linear relationship between the variable X and Y relationship. Okay. Now here, when it is +1, S to +1. Okay. We call it the strong positive linear relationship. Okay, let me make it this way. Strong positive linear relationship. Okay. I'm going to move this a little bit backward. Yeah, relationship. Now, so that means this one is positive. That means when one of the variable increases, the other one increase. I'll give you an example. We increase your hours of study, your grades will also increase, go up. So that's strong positive relationship. Then, so that means anything from here, if your answer for this is 0.8, for example, or 0.8, Okay, that means it's a strong linear relationship. But if the answer is as little as 0.4, yeah, it shows that there's a relationship, but the relationship is weak. Okay, it's weak because it gets closer to 0. Now on the left side, we have the same thing, similar, -1, which indicates a strong negative relationship. Let me write it down. Strong negative, yeah, linear relationship. Okay, linear relationship. Okay, linear relationship. Okay, relationship. So in this case, when one variable increases, the other one decreases. For example, if you increase your speed, then you get to their destination in less time. So the higher the speed, lower the time. So that means strong positive and negative linear relationship. So that means the two variables move in opposite direction. For example, if you have negative 0.9, for example, or negative 0.8, it's strong, there's a relationship. But negative 0.3 indicates it moves closer to 0. That means there is a relationship, but it's very weak. Okay. So these are the range of values for the correlation coefficient. Now, next thing we look at is what we call the coefficients of determination. This tells us is a statistical way of explaining how much a variability in one variable of a factor can be caused by or explained by the other factor. You know, I will show you how to use it when we do the calculations on this. So in our calculations, most of the calculations, we are trying to predict, to estimate the regression equation, which is y equals beta 0 plus beta 1x. Beta 0 is this y-intercept. If you remember your algebra class, y-intercept, beta 0 here. Then the B1 is the slope. So these two parameters, B0 and B1, are what we are trying to estimate when we are deriving the regression equation. Once we have these two variables, we can estimate, make some prediction about the relationship between two variables. Now, other thing we need to compute to calculate R. Basically, to calculate R, we use this formula here. R equals to SXY divided by square root of SXX and SYY. This is just one method of getting the regression. So to calculate this, you have to first of all get this number, this variable, this part of the equations. Sum of SSX, SYY, which is sum of square for Y, and SSX, which is sum of square for X, then SXY, which is the sum of square for the interaction between S and Y, and then to get the slope. So, but this will take you a long time to get. So we're going to be using Excel to simplify the matter, make it easy. Something that might take you up to 1 hour to calculate to finish, except we can finish it in 10 minutes. You know, so we'll be using Excel for this. Now, so when we're doing regression, we're trying to estimate the regression equation and also to estimate the value of our R. Then we need there's other estimates that comes as part of this process. So I'm gonna explain that, how to use them. Now, question before I continue?
No questions.
Good. Now, sometimes we might like to see if there's a variable. When we are doing the regression analysis, we plot the graph of the two variables, the S and Y variables. That can even point us to the direction of the type of relationship that both of them have. So that graph, we call it the scatter plot. Scatter plot. Scatter plot. Okay. So a scatter plot is simply a visual way of describing the nature of the relationship between the two variables. For example, let me show you how it works. If your scatter plot, let's say that you plotted the graph of the two variables. Excuse me. So let's say you plotted the graph of the two variables, and you got something like this. Let me still have this. Okay. You have this. You have your y variable 0, and you have your x variable. Okay. Now, and you have this in this form. This is your graph. And then you have this. Well, move this. Okay. Okay, let me see. I have this form. Okay. You have your x, you have your y. This is 0, 0, and this is your x. So that this one is gone. So now we plotted this graph. You know how you plot the graph? You plot your point. You get x. Okay, so x. Okay. X. X. You plot your point. Getting this. Okay. So you can see that this shows you an upward trend. For example, advertisement, the amount you spend on let's say that X is the amount you spend on advertisement, and Y is the sales you got. So you can see that it's trending up. That means the more you advertise, the more you sell. So this kind of graph, if your points are plotting trending up like this kind of scatter plot, I call it, indicates a positive linear relationship between X variable and Y variable. Okay. Now, if your graph is the opposite of this, okay, let's say that your graph X and Y, okay, let me move to the next page. The graph is like this. Let me see, this is, okay. Instead of trending up, that it is trending down. So you have your X here. Let's say you have your X here. That is the first point. Excuse me. Then the second point. Okay. A third point. Okay. The fourth point is fifth point is now at least trending down like this. Even though we have one that is off a little bit, most of them are trending down. This indicates a negative linear relationship between S and Y. And a good example, speed, more speed, less time, you arrive to your destination. I mean, assuming that you didn't crash the car or that a speed cop didn't stop you, So there are many other forms of the scatter plot. You can see, we can have it in this form. Let's say that it goes this way. Oh, excuse me, a mistake. Let's say that it goes this way. Okay. Okay. Now that instead of this, it just scattered everywhere. You know, it's one here. A point. It doesn't show any pattern. You know, this doesn't show any pattern. You know, so it indicates no linear relationship. No linear relationship between the two variables x and y. I'll give you an example. Somebody that won a lottery here. Let's say that dependent variable. No, let me not use that one. That one is not good enough. Let's say that let's say the x variable is the amount of coal that is produced in US this year, and y variable is, I'm sorry, this s variable is the number of infection, those infected with COVID-19, and y variable is the quantity of coal that are produced. They are not related at all. As a matter of fact, sometimes two variables like that are not related at all might have a correlate. They may correlate or may have a show linear relationship. That is some isolated cases. In few isolated cases, we may have something like that. So now you have seen how the scatter plot works, and like I explained, what we do is we try to estimate the value of the regression the R, which is the regression coefficient, correlation coefficient, the correlation coefficient, and also we try to predict the or estimate the regression parameters BO and B1 by deriving the regression equation, and then we now use the formula to calculate our R. You know, the regression correlation coefficient, which tell us the extent of relationship between the two variables, and then we can plot a scatter plot. And in the process of doing this, we have other statistics we derive. And also, I explained that we're using Excel to make it easy and faster for us. Okay. Now let's do one or two examples here. The first example says, okay, it says a random sample of N steers. Steer is a kind of meat. It says the live weight and rest weight are recorded. We are recorded. In the table below, let's y denote the dressed weight. And then the X is the live weight. You know, the dress weight is different from the live weight. Yeah. And now it says, use the sample data to obtain the least square estimate of the regression equation. That means find the regression equation using the least square estimate. Now, you know that to get the regression equation, you have to estimate the B0 and B1, that is the slope, the intercept and the slope. So using the formula here, you see this the formula for the slope right here. Let's see, right here. See? Now, sorry, for the y-intercept is this, the slope is right here. Now, to save time again, so what we're gonna do to this question is copy this data and paste it in Excel. Live weight and dressed weight. Okay. Live weight. See, this will be live weight and dressed weight. Okay, now it's right here. So live weight and the dressed weight. Okay, this is live weight is S, dressed weight is Y. The live weight is X, dressed weight is Y. Live weight is X. And dress weight is Y. I don't need to write X and Y here, doesn't matter. Dress weight. Wait. Okay. So, or you can make this. Okay. Make it go. Yeah. Now, I gotta undo this. I make it so it's balanced. Okay, good. It's better now. Excellent. Now, so live weight is S, dress weight is Y. So now we can now find predict the regression equation this way. You go to data. Okay. Data analysis. So once you're there, you choose the regression because that's what we are trying to do. Regression. Okay. Give me 1 minute, let me make sure you're seeing this. Okay, good, very good, very good, very good, very good. So regression place, okay. Okay. This is working it. Okay. Now it brings, once you click on, let me show it again because it brought this out. We didn't see it. So once you click, let's start. Let me move this away so I have enough room to see this. Good. So we copied the data from here into Excel and then put in a type of live weight and dressed weight. Okay. Dress weight is the dependent variable and live weight is the independent variable. So we have it here. So we have the in Excel. So let us make the scatter diagram and get the regression equation. So we have, click on data analysis, choose regression, click OK. So you can bring it here. You can see it bring this dialog box. Again, let me make sure you are seeing this. Very good, very, very good. Then the Y range, which is the dressed weight. Click on it. Then start from the title, dress weight, all the way to the last number there. Okay. Now for the range, live weight is the X variable. Click on here, X range, and then okay. Now because you included their titles, you're gonna check labels. Okay. Now we can now look at the check other thing that we need to get from there. We need to get the residuals plots, line of fit plot, which is the scatter plot. Then if we need the residual, we don't need the residual at this point. We need confidence interval, we don't at this point. Okay. Now, in the test for regression, we assume that the regression estimate beta 0, beta I is 0. If you like, I can put that, but right now what we are trying to answer is how to draw the scatter diagram and derive the regression equation. So let us see where we want it to paste it. I want it to paste it right here. So we're gonna put output range. You can paste it here. Once you put it, then output range, choose here. So I choose it, click on output range here, as under it. Okay. Then click OK to give you the results right away. So you can see our R right here, the regression equation, the regression correlation coefficient R. Gotta make this a little bit bigger. So now I think it's to have the scatter diagram somewhere. Okay. Okay, it didn't plot the diagram. Let me see. It should. Okay. All right. Even if it doesn't plot it right there, then we can plot it ourselves directly. In that case, we can just it should plot it, but it didn't plot it. Okay. So if it doesn't plot it at this point, what you're gonna do is just to click on insert chart because you're looking for scatter diagram. You gotta look at this chart. Use this one. You can see this one. Okay. Then oh, I think I did it the wrong way. Let me delete it. Just highlight all this and then click on insert. Put this chart right here. You can see this scatter diagram here. Okay. So you have the diagram and then you can add information to it. We're clicking on this plus sign. Add the trend line. Trend line is the regression equation. We'll give you the regression equation. And then if you want, it's linear. Okay, it's linear and you have more options where you can put the, say, display equation on the chart. I hope you can see this. Display equation on the chart. Sorry, my mistake. Display equation on this chart. And then it's linear. Okay, good. Okay. Then you can then close it. So you can see the equation you're looking for right here. Now let us add the chart title. Okay, put the as these titles. Okay, good. Here you have the y is the because it goes from y value goes for 2 all the way to 2.6. Sorry, this y goes from 2.5 to 2.4, actually 2.1 to 2.8, 2.9. So I can see it right here. Then the x variable is from 4 to, from the smallest number there is 3.4 to 4.6. You can see right here. So you call it this is live weight. And this is your dressed weight right here. Okay, dressed weight. Okay. You can call it figure 1 if you like. Figure 1. Okay. Now, this is the equation we are looking for right here. Let me remove this grid lines. You click on it. Once you click on the line, you can see these dots, and then you press the enter key, delete key. That one is gone. You click on it again, you see these grid lines, press the delete key, and it is gone. Make sure you're seeing all this. Okay, good. Good. Now you can see the equation we're looking for. Yeah. You can copy it and paste it. And paste it where in your answer or your workbook. Okay, have a solution here. So paste it right here. So this equation is show that the slope is x. How do you interpret this? Interpretation. This show that the dress weight increases at a rate of 6.61 pounds. This is pound, I believe. Yeah, at the rate of 0.6163. We call it 0.62 pounds. Each 1 pound increase in the life weight. Now, so let me write it down. The regression, the slope of 0.6163. How do you know the slope? Because it is the coefficient of the x there. Means that the dress weight increases over time at the rate of 0.6163 pounds for each 1 pound increase in the live weight. Okay. Now, at this point, we can answer other questions from that related to regression using the information we have in part in the chart in Excel. So we have the several things here. The result they give us, we have the regression statistics. R is point, let me write it down. R is point. R is point. Let me write it so I can put it there. You can see that R is 0.953. R square 0.9073. So let me explain what both of them means. Before I do that, I want to show you one more thing. So it's 0.952523, but we just round it up to 0.95, and R square is 0.9073, but just round it up to 0.91. Now, before I explain what these things mean, I want to show you something. If you look at the regression equation, see that the slope is sloped. Let me make it bigger. Make sure it makes it a little bit bigger. And see that the slope is 0.6163. If you look at the table of results, see the slope right here. You see that they're the same thing, 0.6162. If you round it up, it gives you 0.6163. And the intercept is 0.086. You can see right here, 0.086. When you round it up, let me increase it, say 0.086. So you can also get it from here as well, as by putting it in the scatter plot. Now, having explained that, let me go to other side to the other workbook and explain the meaning of R squared. Now, in this example, our R, the correlation coefficient, equals 0.95. This is R, small r. I say it's this capital R, but it's small r, because it's the estimate. So we have it here in Excel as 0.9525. So we rounded up to 0.95. It means, what it means that if you remember the diagram I showed you when we were doing it, I was introducing the range of values for the correlation coefficient. You can see what I told you, that if R gets close to 1, you show a strong positive linear relationship between the two variables. So for R 0.25, this shows how we interpret interpretation. This R of R 0.95 shows a strong positive linear relationship between the live weight, dressed weight, and the live weight. Strong positive relationship. That means when the live weight increases, the dress weight also increases. and vice versa. That's what it is showing. A strong positive relationship in between the life weight and the dress weight. Then R squared. Okay, R squared equals, we got the R squared from the graph as 0.9073, which we rounded up to 0.91. Okay, 0.91. Okay, 0.91. Okay, is R squared, small r. So R squared. Okay, so now I can make it bigger so that we can interpret it properly. Okay, so interpretation. Okay, so I'm doing all this example, answering all this question because in a real in an exam I'll ask you, give you something like this, and I say construct a scatter plot, which we did here for this example, the scatter plot. Yeah, right here. This is scatter plot right there. And then I might also ask you, or the question will ask you to calculate the correlation coefficient R, which we just did, and I put it here already. And it also asks you to calculate the R value of R square and explain the results. We have the R square here. That's how I'm about to explain it. So this R square means that we call it the coefficient of determination. It shows that 91% of the change or the increase in dress weight is caused by the increase in life weight. So an R squared of 0.91. Okay. So when I explain it here, shows that indicate that 91% of the increase in live weight is caused, in dressed weight. Mistake. Dressed weight is caused by increase. Increase in live weight. Any question about all this? Any questions?
No, not for me.
Okay, good. Now let's answer the last question that you can see. I may ask you to find what is the predicted price? Sorry, man, this is a different question. I'll ask you what is the predicted dressed weight if the live weight is, say, 7. See? So what is the dressed weight if the live weight is 7 pounds? To do that, you need this equation. I'm gonna copy it down. So predicting the dressed weight. Okay. So I'll ask you, determine the dressed weight if the live weight is 7 pounds or 10 pounds, as any number at all. So in that case, all you have to do is to, you already know that the dress weight is the dependent variable, which is the y variable. So remember the equation is right here. So, and I ask telling you that the live weight is 7 pounds. That means when x is 7 pounds, x is 7. So this means that y will be, now use 7 to replace use 7 to replace x here. So that means y will become equals, hope you can see all this. Yep, see, y will become equals 0.6163. Now for this x, you replace it with 7 pounds. It means then plus 0.086. So this means this times 7 plus that. So let me write it down, then we can now figure it out using the calculator. 0.6163 times 7 plus 0.086. Okay. So in our calculator, we have it in this form. So we have 0.6163, 0.61 times 7 pounds. Okay. Then plus 0.086. 0.86. 4.4, I say 4.4 pounds. So we go there and put pounds, 4.4 pounds, which is 4.4 pounds. So when the live weight is increases to 7 pounds, the dress weight will increase to 4.4 pounds. I think that's basically what linear simple linear regression is about. Any question before we leave?
No questions.
Okay, so let me take down your names. Now, I want to look at the attendance. Remember what I told you, the agreement we had. Those are maintain the good attendance. I'm gonna choose. You're gonna choose my homework. Choose one homework that is you get very bad grades, and then I'll give you makeup. So I would give you 10% on that homework. I'll add 10% to that grade. Just one homework. So I'm gonna check your attendance later on. Then by now next class I will tell you if you qualify for that. Okay. Meanwhile, let me just take attendance for today. We have 5, today is 7, 21. So I got these people. To qualify, your attendance had to be up to 80%. So I got Aaron is here. Anya is here. Chambers. Okay. Bennett is here. Taylor. Okay. So on Monday, I will tell you if you are qualified. You will know when you look at your attendance grade, you will know. Then you can choose one homework or one test, just one. Then I'll add 10% to the score, and then it should be and I will take care of that. Now, please continue working on your project, and I'll see you on Monday. You have a good weekend.
You too. Thank you. You do the same.